Hi. So now let's see scatter plots and correlation heat map. So you know this equation basically. So this is the equation for calculating the correlation coefficient. So correlation coefficient is it describes the relationship between two variables, right? So if the value of correlation coefficient is 1, it means that there is a perfectly linear relationship between the two variables. If it is 0, it means that there is no linear relationship between the variables. But most of the time we know that it will be like in between 0 and 1. So when the value is much closer to 1, it means that the linear relationship is much stronger. If it is much less, it means the linear relationship is weaker. So essentially, both scatter plot and correlation heat map, which make use of this idea of a linear relation between the variables, but in a graphical way we can understand. So let's see how to plot them. So here we are using a NumPy array, and we will be using pandas to handle the data. So this is a random seed. So actually what previously we used data from CSV files, but now we are actually generating our own data, and that too it is a random data. So to generate random data, we have to usually give a seed. So here we are giving the seed as 20. So when we change this seed, our data will also change. We can also randomize the seed. So, but here we are not doing that. We are giving a fixed number as seed, that is 20. And we are creating 4 variables, x1, x2, x3 and x4. So essentially what each variable has like 2500 data points. So what essentially this function means is that it will generate 2500 data points with mean 0 and standard deviation 1. So again x2 is also a similar array, and then x3, so again we are adding some random number to x1. Then for x4 we are adding some random number to minus x2. So essentially now then we are loading these 4 variables into our data frame. So which you can see there is 4 keys, which means that it will have 4 columns, x1, x2, x3 and x4. Then we are trying to describe the data. So here you can see the data description, which has 4 columns, right? x1, x2, x3, x4, and each has 2500 number of variables. So, data points. Then you can see mean, standard deviation and quartile values of each set of variables. Then using this command, we are plotting the scatter plot. So let's see the scatter plot. So essentially scatter plot, this is kind of a matrix where each cell describes the relation between the two variables. So this describes like x1 with x1, so which is, obviously it will be linear. So and so on. So here you can see some of the scatter plots looks like there is some kind of a linear relationship here. All these 4 you can see, and some are like much scattered, which means the linear relationship is much weaker. So now we can actually calculate using this equation the correlation coefficient values and plot them in a similar manner. So that is called the correlation heat map. So this is, you can see the correlation heat map. So how to plot this is, again we have the data we generated. Then what we do is, after generating the data and feeding it into a data frame, using this equation, we are actually calculating the correlation matrix. So this equation will calculate this correlation matrix and it will store the values. Then using this SNS heat map, we will actually plot it in a heat map format. So here you can see some of the correlations are much stronger, which is given like darker color 0.7. And obviously x1 and x1 will be 1, x2 with x2 will be 1, so on. And some are weaker, some are even weaker in negative direction also. It can be stronger in negative direction also. So this is the correlation heat map, which is like a matrix of correlation coefficient between a set of variables. Thank you.